thanks, and good afternoon. So I'm kind of inclined to start out with a survey. How many of you from organizations? How many of you are familiar with SDL processes? You know, okay. How many of you from organizations that have established SDL processes? Fewer. Okay. So what the Black Hat folks and I talked about doing was giving an introduction to how to roll out a security development lifecycle process for an organization that either is new to the process or small and has to, you know, consider affordability in getting started. And so, you know, that's what I'm going to attempt to do here. It's a little bit of an experiment. Just from talking to people at the conference, an email from a friend of mine today, I think there's a population of folks who are trying to figure this out. So it may be of some utility. I'm very interested in your feedback. What I'm going to do is go through a brief introduction to SDL and some of the history and origins. Since you're all familiar with it, I'm going to try to blaze through the SDL history and origins and blaze through the big picture. Just give you a sense of, you know, sort of remind you of what's in the SDLs as they've been created, and then move on to some of the considerations for smaller and newer organizations and some principles that I think are important in creating an SDL process. And then the bulk of the presentation is going to be walking through sort of the big pieces of an SDL in order that I think as a new or small adopter ought to be thinking about doing, okay? And there's a lot of thinks and thinks in that sentence because your mileage will vary. I think that's even on one of the slides somewhere. But I wanted to just give a perspective. How do I get into this without the commitment to do everything? And so hopefully I have 5 minutes at the end for questions, which is what the conference told me to do. If not, we'll have the room across the hall and I can stay as long as you want to badger me. So let's just skip over this. I think you've got it. You're new, you have limited resources, you're small, and maybe you're big and you haven't done software security, you want to get started. Okay, so a little SDL background. Anybody remember Code Red or NIMDA? Not so many. It's amazing there are people in security who don't have that memory. Back in the early 2000s, 2001 in particular, at Microsoft, where I was working at the time, we had a security response process. We were trying to do some things about product security. And in the course of 6 months, we had two amazing internet worms that took over, that basically crippled a lot of web servers, followed by a very embarrassing vulnerability in XP, which was new then. In the aftermath of that, a couple of things. Bill Gates issued the famous Trustworthy Computing Commitment, and I proposed to the management of the Windows division that we shut down all development and take everybody offline and do security reviews of the code. And my boss said, "What, are you kidding me?" This was like in November. And in January of 2002, we shut down all Windows development and did just that. So that was sort of the background of Microsoft and security. We later did what we called an audit, basically go over what we'd done to see how good a job we'd done. And that all worked well enough, not perfectly, for us to say, okay, let's do something permanent. And so the something permanent was the Security Development Lifecycle, or SDL. And the initial version of the SDL was very much taking the things we did in the security push, static analysis tools, code reviews, threat modeling, and spreading them out over the product life cycle that was typical for Microsoft, and saying, okay, developers do this, it's a mandatory requirement. At the end, we'll check and see if you did it. And if you did, then you've met the process and you're good to ship. We'll talk about what happens if you didn't meet the process a little later. We started out with a pretty ragged process. I don't even have a copy of it anymore. But what we did was to make a commitment that we were going to update it every 6 months to a year, and we continued to do that. And that process has survived to this day at Microsoft. There you go. Okay, so there are some strange buttons on this mouse clicker. Okay, so the process that we came up with, the usual slide that we use is this one. Okay, and I'm not going to read you every point on it. I don't expect you to be able to read every point on it. But the important thing here, just in terms of the SDL at Microsoft, a lot of requirements, a lot of stuff spread out over a lot of pieces of the development life cycle for Microsoft products. And so this was a big impact on development. And it was a significant commitment to do it. But as I said, there was a lot of pain underlying making the decision. One important point from this, yeah, there you go. It actually projects. One important point from this slide, at the end there is security response, the old Microsoft Security Response Center. And at the bottom, there's this, I lost it now. There's this feedback loop that says ongoing process improvements. MSRC finds stuff, you figure out why that happened, and then you update the process. So that's the basics of a big SDL. SafeCode, which is a nonprofit where I now work, publishes a fundamental practices for secure development document. This is the chapter headings and subheadings from the new version. And again, the point, a lot of stuff in there. I don't expect you to read it. The slides will be downloadable. But the point is, there's a lot involved in a full scope, big organization SDL. Okay. So what happens if you're smaller and newer? When Michael Howard and I wrote the book in 2006, the talking point that we had at that time was do everything. And we were new, we were probably sort of zealots, and we probably told that to a lot of people for whom it wasn't really realistic. And so, in hindsight, if you're one of those folks, I'm sorry. Big companies write a lot of code. Their products make headlines here at Black Hat, and their products also get attacked. And so, for a big company, there's pressure to do everything. Okay, from the real world. For a small company, maybe not so much. And even if it was, you just couldn't afford it. So what do you do instead? Well, one thing to do is think about your situation. Okay? If you're a small company and folks aren't as aware of you, maybe your products get less scrutiny. Maybe you're just not on the radar. Maybe people don't know. Maybe you can skate along. Maybe you're less critical to customers, although maybe you're not. I have a friend who works with a SafeCode member who spends a lot of his time worrying about software from small suppliers that are delivering critical small applications to their very critical business, and worrying about, what have they done for secure development? How do they gain confidence in the security of the software that they're acquiring. If you're a small company, you probably have a smaller and simpler product family, less stuff to worry about, we hope. And you're probably depending more on code from other organizations. And that's you know, I don't know if you can see the bullets there. The first three bullets are plus signs, the last three are minus signs, and this one is a dot, because it's sort of good news, you're not developing that code, and bad news, you're not developing that code. And then, you know, the negatives, your security team's smaller, your budget's smaller, and maybe your management doesn't understand why you should bother. And that's, you know, those are the things that you somehow got to manage through or overcome. So let me talk about what SDL is, in my view. And this is, I think this is super important. The developers build secure software. That may be obvious, but I've had experience, you know, on a consulting basis, talking to other organizations, that suggests to me that maybe it's not as obvious as I'd hope. You know, your developers are developing the code. They have to make it secure. Your security team may be big for a security team, but it's much smaller than the developers, and they can't make the code secure. The developers have to do that. What can the security team do? Well, they can train the developers, they can provide tools for the developers, they can consult with the developers and advise them on what they ought to be doing and not doing, and they can be checking to make sure that the developers did what they're supposed to do. But testing security in is a losing game, because, you know, if the security team is testing at the end, then, you know, you have this dialogue. I've got this on another slide too. You've got this dialogue. I have to ship. You have to fix that product. I have to ship. You have to fix that product. Not a happy place to be for the security team. And then the third thing, I touched on this in the Microsoft SDL slide. Root cause analysis is your friend. Okay, you sort of drive. It's a little bit of driving by looking in the rearview mirror, but that's better than driving with your eyes closed. And so, you know, the basic idea: what's happening on the vulnerability landscape, and what does that mean for my development and my development process? So, as I said, what I'm going to do is go through a set of slides and talk probably about a dozen, 14 of them, and talk about measures to incorporate in a starter security development lifecycle in my estimated rough, your mileage may vary, priority order. Okay, and for each of those, I'm going to list what I'm recommending be done, why I think it's there, why I think it's important and why it fits there, and then some things about how and some pointers to resources. I'm sort of assuming an organization that exists, doesn't have an SDL, and wants to create one. I am not going into the DevOps or Agile or DevSecOps or the other life cycle models of the day. These are intended to be discrete activities that can be fit naturally where they belong as the developers are doing the process. That may be a little bit of a hedge. If you want to ask me questions about that, I'm happy to take them. And again, I think I promised your mileage will vary. Okay, so first thing, why is this even here? I submitted the slides to the Black Hat Program Committee, and some of the feedback I got from a guy who I respect was, really? A response process is the first thing to lead you to secure development? And he wanted me to take it off and put something else. I just respectfully disagree. Response is fundamental both to having credible software security so your customers will have confidence in what you're delivering, and also to creating and operating an SDL in the sense that, where else do you get your requirements? Where else do you get your feedback? How do you know how you're doing? So response process is important for a couple of reasons. And, and if you don't have one, invest in that before you start an SDL. There are lots of them. There are a couple of ISO standards. One of them is free, one of them is pay. There's FIRST, which is a nonprofit collaborative organization. Lots of guidance on building a response process. And if you're not big, it doesn't have to be big. Second thing, track your security workflow. You have a workflow system, you have a bug tracking system, you have something that lets you know what you've done on your software as you're building it. As you do that, include security in the workflow and bug attributes. And typically, what we did during the Windows security push was actually integrate a STRIDE, spoofing, tampering, repudiation, information disclosure, denial of service, elevation of privilege, a STRIDE effect for every bug, or not a security bug. So every bug had that attribute and a severity. And that gave us a way to know what the security implications of the things that we were doing were. When the tools run, they ought to file a bug in your workflow system. When this process says that you have to do something like build a threat model, that goes in the workflow system, and you check it off when you've done it. And that's your way of managing the process and making sure that you do it and you know you've done it. I've seen attempts to do that in an offline or separate system. I guess it's better than nothing. Much better to have it integrated. There are commercial products. I don't know of free offerings. I wouldn't be surprised. There are commercial products that let you suck in your secure development process, and they'll integrate those requirements and processes into your workflow system. So those are options that you have. But that's just important from the standpoint of knowing what you're doing. And then coupled to that, if you were in Christine Gadsby's from BlackBerry session this morning, she talked about some of this too. Have a severity rating system and a bug bar. Okay, this is a security vulnerability. What kind of impact could it have? What's the severity? What's the priority of fixing it? And in the limit, is it a ship stopper or not? The rating systems, we used the Microsoft Response Center severity ratings. We created a bug bar for Microsoft SDL that is still downloadable from the web. There's CVSS. A lot of people use that. And the important thing is to understand what the impact, what the bugs are, what the severity is. One thing I advise against, early on, we used to try to factor in ease of discovery. How likely is it that somebody will actually find this in the wild? And we used to try to factor in exploitability. Oh yeah, that's a security bug, but nobody'd ever exploit it. I think you can guess how that ends. the basic severity is the important thing, is the important thing to consider. So, so we've got a bug tracking system, we've got a severity rating system, and a bug bar. And now the first real technical activity in your development process that's touching code. And this may sound like a really strange one. Secure your third-party code. Okay. Why would I tell you to do that? Well, because it's 2018. And people aren't, I mean, people are writing code nowadays, but a lot of organizations are building a lot of software using third-party components, open source components, third-party code, integrating other people's products. And if you ship it and the customer got it from you, it's your problem. So a really important thing, you know, you open the web in the morning, you start looking on the web in the morning, there's a terrible vulnerability in OpenSSL. Are we affected? Do we? I see some people in the front row laughing. Are we affected? Do we use OpenSSL? Are we vulnerable? You want an inventory. You want to have thought about what you'll do when a vulnerability is discovered in a third-party component, and you want to be able to remediate and respond and protect your customers. There's a safe code guide that we released on third-party components. That's a free download. There are some commercial tools that help with component management and tracking. But this can be a gnarly problem. I don't say it. It's supposed to ease you into it. This is not necessarily easy, because it can range, you can range all the way down to somebody copied a code snippet and used it. And what do you do when how do you even know if there's a vulnerability there? But very, very important in today's world. And then the next thing is what I call do the easy stuff. If there are compiler options, linker options, good and bad libraries, take the secure ones and build those into your development environment. And those are things that you can do, and the libraries maybe not, but they can be relatively transparent to your developers, so they're low effort and they're high impact. You may say you won't experience these common vulnerabilities, but the mitigations are provided because the environment builders thought they were important, thought they were common, worth having them, worth using them. Okay, everything from here on requires goes beyond the security team. Now everything from here to the end of the deck involves your developers, and to do that you've got to inform and motivate them. My favorite story about this, early on when I was running the response center at Microsoft, somebody came in with a vulnerability report to us. I brought it to a guy, good young computer science graduate of a good school, had just joined the response center as a program manager, and I showed him this report of a vulnerability in some piece of software. And his response was, why would anybody do that? Tell them not to do that. Good luck with that. The developers have to understand that product security is important, and they have to understand that it's their job. And that message has to come from somebody they'll respect. We had Gates' endorsement of trustworthy computing in 2002. One other thing, just sort of a war story that may be sort of relevant to this motivation thing. When we did training, we trained 8,000 people in the course of a week in a big conference room that held 800 or 900 people. And each training session was 4 hours, and we had each training session introduced by a vice president from the Windows division. And after you guys know about what happens when the vice president does the introduction. The vice president does the introduction, says this is important, and then walks out, okay? When we did the Windows security push, the vice president did the introduction, said this is important, and sat down and stayed for the 4 hours of the training, okay? That's about motivating developers. So you need executive buy-in and get the motivation down the organization. And then once they're motivated, then you can think about training them. One of my beefs, one of SafeCode's beefs, is that you go through a college, you get a degree in computer science, you don't know anything about writing secure code. And, you know, so, but I've given up on that crusade. That's just the way it is. And so you're going to have to train your developers to create secure software, and do that for your environment. The more targeted the training is to your environment, to what you're doing, obviously the languages, the development environment, the product set, the technology, the better. There is free training. OWASP and SafeCode are two that you can download and use. Okay. Next step, secure design. Okay. I'm gonna talk about threat modeling in a bit. It actually sort of shows up in two places. Architecturally enforced bad security is a real pain. Okay. At one point, I was faced. What is wrong with this thing? Well, the hell with it. At one point, I was faced with a client-server application that had a thick client and a SQL database, and all the security enforcement for the system was on the thick client, which could have been Windows 98. Okay, and so not a happy story. And architecturally not a happy story. The group that was responsible for that lucked out, but it took years for them to re-architect the product, introduce a middle server-side middle tier, and get the fundamental security off of the product off the insecure client system. How do you do that kind of analysis? Threat modeling. I assume a lot of you were at Adam Shostak's talk yesterday. Threat modeling is the technique, and that's an investment. You may be able to start with a high level, because if you make a fundamental architectural decision like this client-server architecture, you're in a deep hole. So you may be able to start with a high-level threat model and then go back and do more later. You may also just be able to copy a secure architecture if there's one that's around that you can trust. And then a couple more things. Use the platform security features. Don't roll your own crypto. For God's sake, don't roll your own crypto. The platforms or environments you're using probably provide some facility for authentication, for authorization, maybe for auditing. To the extent that those are available, you can use them. That cuts your development effort. It gets code that's probably better quality than you can write if you're just starting out, and it gives you a more secure approach. And you use those features in a secure way. Not only probably in a secure way, it's probably more secure and cheaper as well. And then, next thing, minimize attack surface. Attack surface is a term that Michael Howard created to describe the exposure of a software product to malicious attack, to people trying to go after it. And that can be, open ports, unprotected files, unauthenticated services, and the answer is just use the platform features, use the options you have to close those up. Code Red and the index server ISAPI plugin buffer overrun. I don't think anybody who was affected by Code Red was actually using the index server, but by golly, it was on by default. There was an internet printing protocol vulnerability in IIS a few months before, same story, but we didn't have a worm with that one. Somebody, I had a conversation, somebody was telling me, but we have to leave these things on so they'll be discoverable. And my response was, discoverability means that your system just got owned and a worm just propagated because of some feature you didn't know about and didn't want. So minimize attack surface. A lot of material about attack surface in the SDL book that Michael and I wrote. That's a free download on the web. And then, of course, there are modern scanners that will tell you what your attack surface is and how you're exposed. Okay. Now we're to code level vulnerabilities. Okay. And code level has historically been the major source of vulnerabilities, CVEs, Microsoft security bulletins, which I used to track, and so on. When we started the SDL, when we started the SDL was sort of a kinder, gentler era. We had to worry about C, we had to worry about C++, we had to worry about C#, and maybe JavaScript. Now everybody uses everything, okay? And so the languages have just propagated, and that makes it harder. And that makes it harder for development organizations to figure out a scalable, and affordable secure development process. If you're small, maybe you're not using so many languages, I hope. But the things you need to do are train your developers to write secure code in whatever languages they're coding in, use the safe libraries for things like string handling and input and sanitization and cross-site scripting safety. And then we'll talk more in the next couple of slides about tools for code analysis and testing. Code level penetration testing is a thing. We did what we called penetration testing under the SDL, but that was actually deep, in-depth design review, white box and code level. Penetration testing is, it'll tell you something, but some real, but it's expensive and not especially scalable. So second thing about code, your technology may help. If you're using managed code, you don't have to worry about buffer overruns, although there are other ways to write vulnerable code, of course. And how do you know? Well, that's back to the response incidents and root cause analysis. Focus on the things that are happening to your code. Focus on the things that are happening to code from other companies like yours. And then adopt tools or training or mitigations that address those things. Trying to do everything. If you're small, you're new, you have to focus. And this can be a resource-consuming area. There's no way around it. But maybe if you're small and you're focused, at least that lets you focus your tool investment, your developer training, and the things that you have to do. And when you're doing it, my view is that you want to integrate into development so the developers get the feedback and the developers fix the bugs. Okay, when we did the Windows security push, we were running static analysis, I think every week or two, and had just started to roll out a desktop static analysis tool. But if most of the tools now have desktop, and if you can, that's the way to go, because it gives the feedback to your developers and helps them do the right thing and trains them and doesn't bottleneck. That the after the fact, well, I'll build the product and then I'll turn it over to security and they'll run the static analysis and they'll give me back a batch of bugs, and meanwhile I have to ship. Not going to end well. So desktop is the way. And when you're adopting static analysis, pick your must-fix bugs or warnings carefully. There are stories of big organizations spending tens of millions of dollars to acquire an enterprise static analysis capability and then train it for their code base. But what you want to do one way or another is to get to the point where the static analysis warnings are very high fidelity, because nothing will demotivate your developers like a batch of false positives. So you really would like to to focus there, to pick tools that work for your organization. There are tools and tool options. There are free and open source tools. This slide, this segment encompasses both static analysis and fuzz testing if you're doing native code and you're running C and C++. They're free tools. There's at least one organization that does free scans of code that's being built for open source projects. I think there may be more than one. There are obviously commercial products, and there are also services where the vendor, the service provider, runs the static analysis on your code and gives you back the bugs. And so those are all options. But when you're down here, that's an investment. It's, hopefully it's affordable if you're starting small. And then the last of the sort of developer level things is back to threat modeling. And Adam gave a great presentation yesterday. I won't try to repeat it. There certainly are design level errors. They're bad when they occur. For example, I think Stuxnet exploited like 4 design level, i.e. not buffer overrun, et cetera, code vulnerabilities in Windows. So the design level vulnerabilities happen. Got to do that analysis. I think threat modeling is the best way to do it. Lots of resources, Safe Code Guide, Adam's book, other things that can help you get started there. There are free tools for that. Okay. So a couple of final things. Verify that you've done it. Again, Christine's talk this morning dealt with this to some extent. When you're ready to ship, you want to know that you've met the requirements that apply to that code, okay? And that's not, you know, an after the fact penetration test. You've been tracking the SDL requirements in your workflow system, in your bug tracking system. When you're done, you run a query. Are there any security bugs unfixed? Are there any SDL work items uncompleted? And if they're not, you're probably good to go. And that you can do before you do your agile sprint or before you release this afternoon's update to your web service. So you know, that can be as affordable as you need it to be, but you want to do that, apply that discipline. You want to know that you've done the process. And if you haven't done the process, there's something unfixed. If there's something, you know, where it's still outstanding, why then, yeah, I got it. If there's something unfixed, if there's something that's still outstanding, then your severity rating system comes into play, your bug bar comes into play, and you have a conversation about whether we can accept that risk or not. And the way I like to see the process work is that some security executive who understands security and has a conversation with a peer-level product executive who wants to ship, and they discuss the implications and the risk, and then typically the product executive has the risk acceptance decision. But before that risk acceptance decision gets made, the product executive has heard what he's actually signing off on from somebody who's clueful about security. And that's a good way, if you have the data, to make the process actually pretty honest and effective. Penetration testing consultants, maybe. I'm not super big on them. If you use them, what I try to tell people, you know, make them teach you how to fish. Don't get on a steady diet of after the fact penetration testing. It's after the fact, and you probably can't do anything about the results anyway. And then the final point, almost done, about on time, bug bounty. I've seen things on the web that suggested that people were thinking of bug bounty as an alternative to an SDL. I think of a bug bounty as sort of a way to have the same experience over and over again, and actually not get a different result. I think of a bug bounty without an SDL as a way to have the same experience over and over and expect a different result. You know, have a bug bounty, great input, you know, great way to get reports, great way to engage the researcher community, great way to get input to that feedback loop that tells you how to update your SDL process, but not a substitute for an SDL process. So, last slide on my timer. I think I'll have 6 minutes for questions. SDL can be very effective. The full process, a lot of parts, a lot of expense, but you can stage it, you can tailor it, and it can help you. The principles are super important. Developers build the code that's secure. Root cause analysis drives what you do. And to get started, the key things are response process and know and be able to deal with those third-party components. Last slide. These will be on the web from Black Hat, I believe. So if you can't read them, I don't blame you. But I thought I'd put them up there. Those are all free resources from somebody, guidance documents, what have you. So with that, I think we have about 5 minutes for questions, give or take. Let's see if anybody wants has anything to ask. Go ahead. Sorry.
Okay, so from a security perspective, right, we've been seeing a lot of penetration testing from a binary perspective over here. I think this is one of the first code penetration testing advices that I've seen over here. Besides Black Duck, I think they do something similar along those lines. But from a long-term perspective, right, I think all the penetration testing we're doing is really cool. It's nice, but at the end of the day, it's statistical. And it's just people trying different things to see if they could find a bug. And how it goes is we have different penetration testing teams. Some of them luckily find a bug. They get more popular. And then people think having them on your team as a tester would mean you have more secure software. So we need to be a little careful about that. We need to, in the long run, come up with a more deterministic way of testing things. And we've gotten here because now there's a trade-off between intellectual property protection and keeping people safe. We should have never gotten there, but now we are there. We're going to have to find a line in the middle where we protect intellectual property, but also create transparency, which makes code penetration testing possible in the future. So I'm not, the audio was terrible, so I'm not sure I exactly understood the question. I mean, I think, penetration testing covers a variety of things. You can do code level testing at the end to figure out whether you're shipping vulnerabilities or not. You can do system level penetration testing to see whether your system as deployed is secure. We called white box design reviews penetration testing from time to time at Microsoft, and that's probably just an abuse of the term. The talents that penetration testers bring are important to getting secure code. The challenge, in my view, is to exploit those talents in such a way that you're actually that they're scalable, okay? Proactive then.
Yeah. Yes.
Surprised to see threat modeling so far down on the list.
Well, I'm surprised at that too, okay? And there's a cheat, okay? And the cheat is that, I said have a secure design, have a secure architecture. And you're probably going to do that with threat modeling as well, with a high-level threat model. But pervasive threat modeling, I mean, if you go through the list of activities, I mean, I'm not, it's important, but there are a lot of things that are important in the SDL.
Yeah, I was thinking that it's a good way to shift the higher ups from thinking tactically to start thinking strategically when they can see the big picture.
Yeah.
I see people saying, let's do two-factor analysis. I'm like, yeah, that's great. That should be.
Let's do what? I'm sorry.
Let's do two-factor authentication.
Right.
Well, that should be like number 10 on their list, but they're thinking very tactically.
Right. So I'm talking product and software level, and at the system design level. I mean, actually, you can argue about whether that architecture example I showed was was that a software vulnerability, or was that a system level vulnerability, deployed system vulnerability? It was something that had to be fixed. Threat modeling reveals it, but it high level and critical, because that's the sort of thing you really want to avoid. It's baked in there, and it's going to take years to get out. Yes, I think last question, I think last question.
Where do you really start for the first time? So if it's a small company, 20 people, that has never done security, and they want to start, where do you start?
Where do you start with a small company that has never done security before? tough question. Find the likeliest suspect. You know what I would say? Find the likeliest suspect in your development staff, and by that I mean the person, who breaks into other people. Well, find the person with the right attributes and get him or her to start to look at some of the literature, maybe go to some of the conferences, look at some of the online content, the videos, what have you. Start to think about what you can do to get started. And I think that's probably a good way to ramp up. I mean, you're talking, I presume, I can say hire somebody, and that's probably easier said than done. I can say hire a consultant, and that might be doable. But, again, if you hire a consultant, make him or her teach you to fish. Don't make him deliver you fish every week, because that'll be a big bill, and you'll have a lot of dead fish around.
I really meant to ask, which technology do you start with first?
I'm sorry?
Which technology, what solution do you first implement, the low-hanging fruit? Where do you really start? Which technology? There's so much out there.
So that really, in terms of which technology, that really depends on your company, your code base. I mean, if you're building a security product, start there. If you're building, something that's on the web and dealing with sensitive data, start there. In terms of the technology, do you do C? Do you do Python? Do you do JavaScript, Java? That's really going to depend on what your development environment is. If you're starting from scratch, pick a managed code language that, where there's good security reputation. Okay? Thank you very much.